Very good morning to everyone. I welcome the resource person for this session, Dr. Khyati Vora, Principal Dr. Sridhara Shetty, Vice Principal and IQAC Coordinator Dr. Liji Santosh, Vice Principal Professor Sandesha Shetty, all my colleagues and my dear participants, to the first session of the third day of 10 days virtual workshop on research methodology in social sciences organized by the Internal Quality Assurance Cell of Bansanga's SM Shetty College of Science, Commerce and Management Studies in association with Indian Council of Social Science Research. We began our workshop on 18th of April with a series of enriching sessions conducted by eminent research scholars. Till now, we have covered a multitude of topics comprising basics of research, review of literature, up till formulation of hypothesis. Today, we would be starting with the session on hypothesis testing. And for that, we have amidst us Dr. Khyati Vora. Dr. Khyati Vora is Assistant Professor at KPB Hinduja College of Commerce. She is in academic field since 2007. She has also worked as coordinator for BCom Financial Marketing.
Avoid this. It's okay. It's already done yesterday.
Ma'am, there might be few of them who would have joined today. So
okay.
Couldn't go without introducing you to them. For 8 years. She has pursued her PhD in Business Policy and Administration. She's a recognized PhD guide at University of Mumbai. She's a member of ad hoc Board of Studies of BFM at University of Mumbai, KJ Somaya College and MCC College. She has more than 50 of her research papers published in various national and international journals. Not to mention, many have been awarded best papers in national and international conferences. She has been a resource person for many of the research methodology workshops. And ma'am, we are extremely grateful to you for accepting our invitation and we look forward to learn from you. I request the attendees to put your doubts in the chat box and ma'am will answer them during or at the end of the session as she prefers. Without further ado, I request you ma'am to take over the session. Over to you ma'am.
Thank you. Good morning everyone. So here we are today to start with the little critical topic, that is testing of hypothesis, the soul of the entire research. And before I go ahead, I'll just take a short tour of research that we have studied so far. So there is something like topic selection, then you get into a review of literature, you choose your variables. Depending on your variables at what you want to study, you started collecting the data. And once the data is there, now there is a lot of awareness. First awareness never comes in complete. It's always in half awareness initially. And this is very dangerous. So many of, like me initially, were very passionate and crazy for using a very fancy test like regression, SEM, ANOVA, Mancova, and that looks so nice that yes, I have done a very good research. But if the concepts of this testing of hypothesis are not clear, then you will end up making a biggest mistakes and the results are very absurd. So I'm not going to touch more of the statistics. Yes, I will see. There is always a question amongst all social science researchers that are we supposed to learn statistics? How much I should know about statistics? Because statistics apne aap mein bahut bada subject. It's a huge subject in it. If you go in detail, then there is a lot of things to understand. Now there are two things. One is to learn to drive the car, and second, to know how the car is being driven, why it is so, what is happening if we get stuck somewhere on the road, and how to manage that. So what I have this answer for this question is how much statistics you should know, at least to handle the problems that you face during your PhD. If not able to apply those statistic tests, you can always take an help of the research consultants or the statisticians. They will help you applying the test. Now there are a number of softwares available like SPSS, R, eViews and MOs, and then there are many more coming up. These softwares are very easy to use. If you know the simple steps, you can run any test. Even if I give them any stupid data, they will understand anything else. They don't understand concept. if I give an input to them about age and height, so there is a connection. So with the increasing age, the height increases, but till what extent? After a certain time, what will happen? 25 पे height बढ़ा, 30 पे भी height बढ़ा, 40 पे भी height बढ़ा नहीं. But then software will not understand the concept. So they will simply give you the regression analysis, and they will show you that with this increasing age, the height increases, or with the increasing age, IQ increases. But that is not relevant conceptually. So your conceptions, your concepts, your conceptual framework should be very, very clear. You should not go wrong there. Then if you apply your data on statistics, that gives you an appropriate results. So how much you should know about statistics is about which test to apply, what are the critical assumptions of those tests, and how to interpret the results of this test. If you know these things, then I guess it is fair enough for you all to go ahead and take up any research project properly, and you can come up with a very appropriate result. So today what I'm going to do is learning objectives, fundamentals of hypothesis. Like yesterday, we discussed about what is hypothesis, null and alternate, and how to derive to hypothesis, how to frame hypothesis. Today, at the end of the session, you should know that which test to apply and what are the results and how to interpret those results. Then we are going to talk about story of significance. Then what are the assumptions of choosing a proper test? This is a very, very important secret. This is a whole in the statistical part of your research is a very important area which most of the researcher neglects, which is very important to know. If you know this, I think the chances of making mistakes are very, very less as far as your statistics and analysis are concerned. And then again, choosing the appropriate test. Now let us come down. Okay, so now here we are starting from the data has been collected. I have a huge questionnaire and I have the Excel sheet with me where all my data are available. Remember, in your PhD especially, not in your research paper in particular, in your PhD especially, when you are collecting data through questionnaire, there are 3 simple analyses that you should go ahead. There is a process. First will be, you should go with, during a pilot study, confirmatory factor analysis. If you are using exploratory factor analysis, fair enough. If you are not using exploratory, then you should go with confirmatory factor analysis. Now, what is this confirmatory factor analysis? I think CP Gupta sir, when he's going to discuss questionnaire, will surely attend this, but I am giving you a very short idea about it. Once you prepare a questionnaire, that becomes a scale through which you are collecting information. So don't you think I should first check that whether the scale is appropriate of collecting this data, and will it give me a right kind of information? So that is, if you all are aware about reliability, validity check of your questionnaire, so the outcome should be your confirmatory factor analysis, which shows that yes, those factors that you are talking about are making those constructs and they are reflective scales and they are ready to be used for further analysis. So in your analysis chapter in your PhD, the first thing comes is the descriptive analysis of your respondents. Most of us felt, even I, that showing the tables and the graphs about the counts, the percentage, the mean score, and cross steps, how many male, female age groups and education qualification, and what are their opinion about. If I'm asking them in a scale, then highest satisfaction, how many people have given selection for the higher satisfaction to the lowest satisfaction. But these are not your inferential analysis. These are descriptive analysis. In a simple term, they are tabulation of your data. You are organizing your data, that's it. You are not drawing any inferences. You are not coming up with any hypothetical scenario. So first will be descriptive analysis. Again, at the pilot study stage, you have done your CFA. You will redo it, your CFA again, saying that yes, this is my confirmed factors, and now they are ready for the inferential analysis. And the third stage comes the inferential analysis, means you have selected a hypothesis, you have framed a hypothesis. Now you need to choose an appropriate test to check whether whatever hypothesis you have developed, whatever assumptions that you have made before starting your study, were they true or not, with the data evident to it. And remember one more thing, this thing, some small things I always feel like sharing with all the friends. There is, whenever you do research, it's not you are going to conclude. It's a data that concludes. It's a data that gives you the findings, and not you and me. And hence, in the research report or in the research paper or in PhD thesis, we never write I, we, you, her, she. We always refer ourselves as a researcher. We always refer others' paper as an authors. We never mentioned. Why? Because these are the authors, these are the researchers. They have taken a data, they have done an ROL, and on the basis of that evidence, we are saying that yes, yeah, facts hai, and these are the conclusions because of these facts. This is what they are showing up, and not me. See, understand one more thing. If I, as a Khyati Shah, is going to make any statements and I'm going to come up with some results, I need not need data. I may collect data for my own understanding, but that becomes article. That becomes like writing a blog, writing your own thoughts, like an essay. But it doesn't become research. It becomes research only when those ideas or assumptions are backed with a strong evidence of data. So this is a very important thing. Now, one more information that I would like to share with all the participants, that at the very higher level of your research or in the very renowned journals, that what I have got to know is, initially when I started learning research, I started writing conceptual papers. And those papers just were about concepts of those particular area and a lot of descriptions. But then at the certain stage, I felt, no, this is not the quality research. This is not done. We need to collect primary data. And then now I realize it is ROL. But when you write enough research papers, when your papers are accepted in various journals, corpus journals of renowned journal, and you become an authority to speak about that particular area. Say, for example, I am writing on higher education. I've been writing for years together. I have done a lot of research and a lot of my papers have been accepted in a Scopus. So now I am a celebrity in that particular field. If I write a concept paper, people are going to listen to me, because that is a name, that is a person who have done a lot of research, and not Khyati Shah. So you should know the difference between the both. So let us come back some ideas about data analysis. We won't waste time, because today I want you all to, at the end of this session, the concepts regarding hypothesis testing should be very clear. If not, you understand statistics, that is okay. But conceptual understanding hona chahiye. So what is the, now once a hypothesis is set, your data is there. Now what next? It has to be statistically tested. Only through this description, you cannot test hypothesis. If you have framed a statistical hypothesis that there is no significant relationship or there is no significant differences, you need to have some statistical background, for which you need to choose an appropriate test. Now, why I am emphasizing more and more on appropriate test? If I want to eat banana, how will I eat? Will I take a big knife and cut it? If I want to eat grapes, how will I eat grapes? If I want to eat pineapple, how will I eat? So understand that whatever hypothesis you have framed, the variables that you are talking about, the scale of measurement, depending on all these factors, you have to choose a right test. If you choose a wrong test, results are absurd. They are not going to give you the clear picture. Then indicator of testing this hypothesis. How I will know that hypothesis has to be accepted or rejected, or whether it is not accepted? What are the different parameters and assumptions of using those tests? Okay, so now after conducting a test, there will be some results which will tell me whether the hypothesis that I have set it should be accepted, or I should fail to accept it. We don't use word actually rejected, but in layman language hum bol dete. In pure research, we will say either it is accepted or I fail to accept the null hypothesis because of the evidence that I have collected, because of the data that I have collected. So under the hypothesis, how to measure, what analysis will give me is the significance value. क्या आएगा? Significance value. Outcome of the test is either hypothesis is accepted or rejected, as I mentioned. Statistically, significance value, we use p value. P value means significance value. It's an parameter. जैसे हम बोलते हैं ना, I got 35 marks out of 100. So did I pass or failed? So if I say, okay, 40 was passing, you failed. So I said failed only when I knew 40 was passing. So there is some fixed parameters for which you will decide this side or that side, accepted or rejected. So that parameter, that benchmark is p-value. That p-value, after every test it is conducted, you will get a p-value in your statistical table, and that p-value, through that you will judge whether your hypothesis has to go or to stay. The p-value is used to represent whether the outcome of the hypothesis is have a significance enough to be able to reject the null hypothesis. See, I told you in the last PPT that most of the time the idea is to reject the null so that the story continues. If the null has to be accepted, the story ends. It means the conceptually you have taken up something very wrong, and there is no significant relationship between something, and you are just putting your efforts to understand the relationship. Most of the time, not always. So you want your null hypothesis to be rejected so that your alternate has to be go, and then you work on it and what kind of relation is there and how it is a cause and effect relationship and going ahead. It lies between 0 to 1. So any significant value cannot be more than 1 or less than 0. It has to be 0.000 something. The p-value is more than, okay, what is a thumb rule? If you do not know anything about this, the thumb rule, you can just note it down anywhere if you want, that whenever a test result shows a p-value which is less than 0.05, the null hypothesis has to be rejected. You should be very happy. You should look forward for such kind of results. Yes, my null hypothesis or the hypothetical value of the p-value is 0.023 or something like that. It means it is less than 0.05. Your null hypothesis has to be rejected. It means that you fail to accept it. And if the null hypothesis is more than 0.05, you have to accept the hypothesis, saying that there is no significant relationship, and you have to close the chapter. You had spoken about explaining the importance of using the word significant, and yeah, that's what I'm coming to this word. Why significant? See, tell me a very simple way of giving you this idea of significance. I have this habit, as a student, whenever something is very complicated, I want to really put it so simple that it goes so easy, because I feel there is nothing like difficult until and unless you don't know the secret about it. Once you know all about it, there is nothing like difficulty, right? Significance is, I will give you one medicine. In pure science, there is no significant value. It has to be straight. Either that medicine works or it doesn't work. So you have a stomach infection, you go to doctor and you say that I have this stomach ache, what should I do? The doctor gives you, ye pill le, 95% chances hai ki acha hoga. 5% I really don't know. Does it work that way? Correct. So what happens? You want 100% result. That if this medicine is given for this disease, is just to cure, apart from all those other diseases controlled in that body, that is science. But in social sciences, and see, in pure science, A plus B is equal to C, it stays constant in a given circumstance. It doesn't change. The chemistry, the chemical values doesn't change. But in our human science, in social science, we study perceptions, behavior, we study awareness level, satisfaction level. It is a human behavior which has some variances. There is always some chance of by chance ho gaya hai, exact nahi hai. So we are inconsistent. We are heterogeneous, though we are homogeneous, but we do have a heterogeneous quality. Because of which, in social science, we give out of say 1, we give 0.05% chance कि ये शायद कुछ अलग results दे सकता है. So hence we use word significantly, sufficient enough to say that yes, 100% data ऐसा नहीं बोलेगा. जैसे कि मुझे बताना है कि all the participants were satisfied with my workshop, with the workshop of SM Shetty. So do you mean that everybody will say yes, we all were highly satisfied? No, there will be people who felt that they were not so satisfied with some parameters. But we say it is a significantly, data is saying that they are significantly satisfied. So you got the difference. But in pure science, you cannot use the word significant. Most of the time they don't use. In fact, in their science also there are certain circumstances. Like we have seen in COVID, doctor have tried all things on us. ये medicine नहीं करो, ये medicine and ये नहीं तो वो, and the whole India is was surviving on Dolo 650, right? So let us come. Hence, I say that we should use word significant. That is the importance of using word significant. See, again, in hypothesis, no, like in our jurisdiction, we say that in the court cases, the judge says that you are innocent until you are proved to be guilty. So in the order, usually they write that since there is no evidence that the person has to be lived as and is not guilty for that work or is innocent. So that's the formula that we use here. That we don't have enough evidence to prove that the data had some significant impact on something. That's how we go. Okay. Now let us come. Okay, there are questions coming up. No. I think I will answer these questions after each concept that I complete, right? Thank you. Okay. Then example of statistical test reporting out of p-value. Here are some example of hypothesis, null hypothesis. Now, yesterday I told you that why you should be using null hypothesis. That most of our test checks on null. They don't checks on alternate. So what are the assumption of the test before? Yesterday I also showed you that how you're in a pathological studies, they will assume that you have this disease and they check the sample for the absence of the presence. If it is present, they say yes, what is what we assume that you had a disease was positive. But in our social science, we have, I think there is somebody who is raising the hand.
Ma'am, you can answer him later, or you want to answer
Exactly.
now?
I think, we only have 1.5 hours and I have a lot of content to discuss. So what I thought is, sir, Chandrasekhar sir, you have some questions to be put up. Can you just note down this question and ask me at the end of the session, sir, so that we can complete the entire thing? Thank you. Okay. So where was I? So two sample t-test, linear regression, and some of the examples, how they assume before checking the data. They say that the true difference in the mean of two samples is equal to 0, and that is null for them. E0 means nothing. So that is an assumption for them. And if the test result is 0.05, less than 0.05, we say no, this is not accepted. There has to be some difference, and alternate is accepted. And otherwise, similarly, linear regression, the coefficient of the x variable has to be 0. They say it's 0. Let us assume it is 0. And if the test value says no, it's not 0, it is 0.05 something else, then we say okay, statistically the null has to be rejected and alternate has to be accepted. So this is just in some of the example to give you more conceptual clarity. Okay, probability of seeing the effect when the null hypothesis is true. Just giving an idea about how a formula looks like when you study the p-value. Just a second. It got stuck somewhere. Just a second. I think there is some problem with it got hanged. Give me a minute, Amma.
Participants, ma'am is facing some technical issue at her end, so kindly wait until she rejoins.
Mithilesh, please make a note like when ma'am joins.
Yes, ma'am. We are keeping a note of that, and as soon as the ma'am joins, we'll make them co-host, ma'am.
Everything was going smoothly. Don't know what happened. In the meantime, dear participants, we have 3 different sessions today by 3 different resource persons. So stay tuned and don't miss anything. Next session is from Anil Sutar. He is from Tata Institute of Social Science on sampling and selection of sample size. This time we have included it is something very different, and that is done by Priyanka Dwivedi, Health Science Department of Tata Institute of Social Sciences. So don't miss this too today and enjoy the sessions which is coming ahead. Mithilesh, can you just explain how can one join Telegram group? Help Amitabh Avinash to join our Telegram group. He is trying to join, but he's saying like he's not able to join with the link. Do you have an app on your mobile or on your desktop or Amitabh? Have you downloaded Telegram app? Yeah, then Telegram has to accept your phone number. They will give you a call. We have actually uploaded all the sessions videos on our YouTube channel. Okay, please visit our YouTube channel. Everything is available. Yes, yes. All are there on YouTube channel and it is going live right now on YouTube. Do not worry. So Amitabh, if it is not happening, at least send it again. You know, like you can reinstall the app and that will help you a lot. Sometimes it takes some time. Once the app has accepted your phone number, then automatically you can join our thing. I think your app has not accepted your phone number. Actually, it gives you a call which you should not accept just to verify the number. And once your number is verified, you can see many people from your contacts are there on Telegram. And later on, you have to accept the link and directly join. Okay. Thank you, people, for stopping the recording. Where is Khyati ma'am? What happened to her? Participants, you can ask any general questions if you have. Now.
Amitabh sir, if you click on the link for Telegram group, it will directly open in Telegram app if you have it installed. Mithilesh sir, ma'am has joined, so you can make her the host.
Done, ma'am.
Yeah. I'm so sorry. There was some problem with the laptop.
No problem.
Yeah, we can start again. Okay. So now we are going ahead. Until now, we got the idea about what is significant value. So when we test any analysis we do, or we can take up any test, what is the outcome and how to interpret. And we'll keep the parameter of significant value of 0.05. It is a confidence level also. It is known as confidence level also. But if you want to know more about p-value, then you need to really attend some statistical programs and get into the entire, it's a complete analysis. Now we're moving to the next question is, once I collected my data and then there was an hypothesis whether A influences B, which test should I use? So this test, statistical tests are broadly categorized into two. One is parametric test and another is non-parametric test. The question in everybody's mind, most of the researchers get confused, which test should we apply? Whether should we go with parametric test or non-parametric? Now, which test to apply depends on the parameters that you have choose for your data collection and other things. And once the data is collected, so there are assumptions you have to check before using parametric test. For non-parametric, there are no much assumptions. Okay, so now whatever I'm going to share with you all are very important information. That what is parametric test? The family of this parametric test, or all those tests that falls under the parametric test, works on mean. The analysis that they drive at, any regression, correlation, or binary regression, or any kind of this analysis, or a t-test, any of those tests, they all work on mean. The mean of the data is being calculated, and then there is a process, or there is statistical calculation. And mean is a very purest form of understanding the central tendency of that particular data. Hence, it is said that if you are checking your hypothesis through parametric test, the results are more near to accuracy. They are more relevant. They are more good result than the result that comes from non-parametric test. So there's a basic fundamental between the both is all tests under parametric test works on mean, and under non-parametric, most of them works on median and sometimes on mode. So this is a basic difference between parametric and non-parametric test. The t-test rests on the underlying assumption that there is a normal distribution of the variable and the mean is known or assumed to be known. The population variation is calculated and the sample is assumed that variable of the interest in the population are measured at an interval scale. Now, what they are talking about? They are talking about the assumption that one needs to check before choosing parametric tests. I'll give you a very simple example. I think yesterday I couldn't use whiteboard. Again, today it's not possible, I guess. So I will use my slides. Okay, this is a blank slide that I'm using to explain you that why the results of the mean are more accurate than the results based on the median and mode. Now, my simple question to all those who are there and not very clear with the ideas of mean, median, and mode, and what is its impact on the parametric test. Also, we want to check their marks. I want to know the overall performance of the students in the class. I'm giving some practical examples. So I have three ways of doing it. We all know there is a central tendency theorem that mean, median, and mode helps us of doing it, right? When I calculate a mean, my data, the data that I have collected is, and the 10 students data says, some have got 45, some have got 40. Okay, I'll give a higher mark, 65, 60, 70, 75, 60, 65, 68, 72, 70, 1, 2, 3, 4, 5, 6, one more, 70. Now tell me what could be the mean of this numbers that I've shown you when I calculated the marks of some subject. It should be nearly about 70, some number near 70. I don't have an exact number, but something near 70. This is a mean result. Now, what if my data was such 65, 50, 60, 75, and 68 or 58, or we'll say 68. Somebody got 35, somebody got 90, 45, or somebody got again 60, 65. What will happen? Okay, we'll do it this way. This is again 70. What happened in this data? In the earlier data, if you can see, there was a near about relationship. They all were rotating near mean. Any value were not so far from the mean. So then we can say that on an average, the class students are getting 70. But if I calculate the mean may drastically drop down and show something around 50, 55 or something like that. If there are two more such values, which is not the part of the entire group, they're not the group represented, then it can be possible that there is only one student is getting very less marks, rest most of them. If the 9 students, अगर मैं इसको निकाल दूं, इसको मैं निकाल देती हूँ, तो वापस मीन बहुत अच्छा हो जाएगा. लेकिन मेरे कोई एक दो वैल्यू की वजह से पूरा मीन डिस्टर्ब हो रहा है. So now what to do? So when you collect the data, आप ऐसा करोगे कि नहीं ये मेरे responses में नहीं आएगा. That is not possible. When you are collecting a quantum of data of 1,000 respondents, there can be possibility that the responses were not proper. Somebody really didn't felt, maybe out of this 120 students in the research workshop, there may be 2 students who did not like it at all, and thus they fall in this group. If I have to judge the quality of the workshop, should I consider the responses from these 2? There is a question mark. Conceptually, उसको हम रहने देते हैं, but otherwise, so what can be done? उसको निकाल देंगे तो भी नहीं है, क्योंकि फिर डेटा का एसेंस कम हो जाएगा. In this case, don't you think we can take up median or mode? More the number has been repeated. More the number has been repeated. And median में क्या करते हैं? Ascending and descending and take a middle value. So when I'm ascending these numbers, what will happen? Automatically the extreme numbers either goes up or goes down. And now I'm taking some mean, and which is again a good representative of the data, but not pure as mean. And hence we say the parametric test results are very good qualities because all those tests works on mean. But there are assumptions, there are conditions under which you can use parametric test. And under non-parametric, we won't say the results are completely bad. They are not so good like parametric, is because we are losing the importance of the extreme values. Then we are losing the importance about getting the more accurate results. And standard deviation will be much more in case of median than in mean. Mean में जो mean value है उससे सारे units बाजू-बाजू में आएंगे. It's not necessary in the case of median. So these are the reasons that why you should be having parametric test over your non-parametric test. I guess rather than going theoretically, I've made the concept clear to everyone, that is what is parametric test. The test that relies on the mean. It gives a pure form of result. It gives a more accurate result. It has its own condition, which I will discuss in the next. Non-parametric is defined as an hypothesis test which is not based on the underlying assumptions, does not require population distribution to be denoted by a specific parameters. They don't need any parameters, and most of the time they work on the median. Okay, I'll go to the next one. difference between parametric and non-parametric automatically जब मैं assumptions बताऊंगी clear हो जाएगा. Now, what are the assumptions that I have to check before using parametric test? I hope you all are clear that why we use parametric is mean. You have to remember that thing. Huh? Only then you will be able to understand all these out of 5, at least 4 things clearly. The most important assumption that one should take care when they are applying parametric test is measurement of scale that they have used in their questionnaire. Normality of the data, homogeneity of the data, linearity in the data, and independence of the data. These are the 5 assumptions. I'm going to concentrate today to help you, all those researchers who are in the urge of preparing their PhD or who are at the end data collect ho gaya, to thoda difficult hoga to check all this. But there are some solutions also. But those who are in the very, they are very freshers and they are framing their hypothesis and they are about to set their questionnaire, please, please, please look at this. And if you take care of these parameters, definitely you can go ahead with the parametric test and you will have a very good results. Is there any questions coming up in between? Mean is affected by the outliers. Where is somebody is given a good answer, outliers that I'm going to come up with. Okay, the first thing is measurement of scale. What is this assumption? So I'm going to deal with each assumptions in a different way. So my first is measurement of scales. We said types of data. Usually measurement of scales are see in question there are 2 parts, questions and answers. In a questionnaire, there are 2 parts, questions and answers. That answers are measurement of scale. How am I measuring the responses that is coming to me? How am I measuring? 2 ways. Gender, male, female, and others is in one way of asking it. You can ask, are you a female? Yes or no. So yes and no measurement scale hua. In the earlier question, when I said gender, male, female, and others is in another way of asking. So these are the measurement scales, the way you are collecting your responses, which is broadly classified into 2, non-metric and metric. Non-metric data is nominal and ordinal, metric is scale and ratio. So what I thought, rather than getting into deep discussion, because the entire lecture is required to understand all 4, I thought I'll give you some practical examples quickly and check whether which kind of data is what. And then, because this requires a lot of time, and I think in one of the session at SM Shetty in the earlier workshop, I have taken up this entire session on what type of data, how to frame it. It comes under questionnaire. Okay, now the first assumption is that if your data that you have collected falls in the category of non-metric, you cannot apply parametric test. To apply parametric test, you should have a metric data. What the idea? Now you will say, ma'am, how will I know? So when you set a questionnaire, you need to check this. Nominal data is a data which has a name. Ordinal data that has an order. So these are the complex understanding. And I'm going to make it very simple after I give you some examples. Scale data, when you scale something, which doesn't have a nature of quantifying, but we are quantifying for our understanding, like behavior, perception, satisfaction level. Temperature may not be quantified, but then we said in absence of temperature, we said, okay, 0 means there is no temperature. Means what? Does it really mean there is no temperature? There is no heat in that temperature. So we are creating that scale for collecting the data. So that is interval. Interval doesn't mean ordinal. There's a different issue about it. I'll explain to you. And the last is the most purest form is ratio form. Something like which can also have a decimals and which have an absolute value where 0 means 0. How many people were there in the room? 0. So there is 0. It doesn't mean anything. There are no people, that's it. So it has an exact value. Whereas in scale, 0 doesn't mean 0. I said, okay, you tell me, are you happy with my lecture? 0 to 3. 0 means you are not happy. But you are not happy is a negative feeling. But feeling is there of not being happy. Correct? So that is a scale. But when I said, did you attended the lecture? No, 0. So that's how we say ratio data as a purest form of data. So now let us check this. Quickly, I want everybody to participate and tell me. So there is a question. Usually we all have demographic questions. So gender, male, female, and others. Location, where do you stay? Western, Central or Harbour? Type of college you are teaching, aided, unaided and semi-aided. What kind of data is this? Nominal, ordinal, interval, scale or ratio data? Oh wow, there are students who knows about it. Very good. I'm very happy that people nowadays are aware about this concept, nominal data. So tell me quickly, most of you have got the answer. It's a nominal data, it's a name. It has no statistical significance. Tell me which kind of test you can apply on this data. The test you can apply on this data. Okay, what can you find out of this? Okay, non-metric pata chala, non-parametric. What can you find out of this? What else you can okay, quickly tell me the mean of gender. Can you tell me the mean of gender? No, you can only find two things. One is count. Just a second. Just a second. By mistake copy paste kiya hoga. Only two things can be done here, two analysis. One is count, exact number of male, female and others, exact number of people staying in Western, Central and Harbour, and aided and semi-aided, count and percentage. And max I can do a cross tab. How many male are from Western region? How many male are from aided college? That cross tab, that's it. So I hope you got the idea that nothing much can be done in this kind of question. My question to you all is, whether do you teach in aided college? Yes or no? Which kind of data is this? Do you teach in aided college? Yes or no? Which kind of data is this? Again, nominal, because yes and no has no relevance. It is just a name. So again, you cannot do anything else, but you can just find the percentage. How many of them said yes? How many of them have said no? You cannot find out mean score in yes and no. Now tell me here, which kind of data is this? Do you think this is an interval data? अभी आया था ना, मैम ने बोला था इंटरवल, देखो 21 से 30 इंटरवल है, 31 to 40 इंटरवल. No, interval data or a scale data is a data where we assign them the intervals, and that intervals I'll tell you in the next slide. This is not the interval data. This is ordinal data. There is an order. Somebody who falls in the category from 21 to 30 is younger than 31 to 40. 31 to 40 is younger than, so there isn't some sequence. In this, there was no sequence, like male, female भी पहले लिख सकते हैं, Harbour पहले लिख सकते थे, Western नीचे आ सकता था, but here we cannot do that. There is some ascending, descending order, and we say it is an ordinal data. So once there is an ordinal data, what analysis can you do? Count, percentage, and you can find the order of something. You can say that somebody who is earning a per month income from 25 to 50 maybe have a less standard of living than somebody who has 50 to 75, or somebody is more rich or poor, something. Somebody is more educated once with their PhD, UG is less educated, something like some inferences you can draw still. Correct. But moment you put in education, UG, PG, PhD and professional, it automatically comes to nominal. It will not stay here as an ordinal data, because profession is one of the category. You cannot compare PG and profession as something like that. It's an educational system that is giving you a certification. This question, next question. So you got to know two data. One is nominal, one is ordinal. Order, something has an order. Now we are moving to the question, are you satisfied with the workshop? Yes or no? Which kind of data is this? When I asked you, are you satisfied with the workshop? Yes or no? Are you aware about this? Yes or no? Do you have a perception for this? Yes or no? You are diluting the essence of the responses. What will respondents will do? Either take on yes or no. What max you can do here? Count, percentage. That's it. But what if you ask somebody, rate the satisfaction level for the workshop on These intervals, these highly satisfied, too satisfied, too neutral, too dissatisfied, they have an equidistance. Hence, we say it's an interval. Equal distance. Like 5 as an highly satisfied, 1 as an highly dissatisfied. 5 to 1. But they are equidistance. 5 to 4, 4 to 3, 3 to 2, 2 to 1. I can also say neutral is 0. Dissatisfied is -1. Satisfied is 1. Highly dissatisfied is it's a +2. And highly dissatisfied is -2. Then again, I'm assigning an interval to my responses. Hence, we say this is an interval data. But in normal language, we say scale data. But what will now happen, apart from count and percentage, you can go ahead and find a mean. So mean cannot be found in the earlier two cases, in nominal and ordinal. Here you can find the mean of something. I hope things are getting little clear. Now we move to the next level. Under scale data, here, do you think I can judge the performance of the entire workshop and as a satisfaction level of the respondent for the workshop just by asking one sentence? Or workshop contains some attributes? Do you think workshop contains like quality of the resource person that we invited, the content covered, the coordination system of the teaching and non-teaching staff, the structure of the workshop? This all together says that yes, this is the satisfaction level. So you should have a reflective formative scale. So this is in terms of scale, or this automatically replaces the nature of ratio data, and then it is ready to be judged to go ahead with the parametric test. So your measurement scale should have this kind of questions. Only then you can say that now you can use parametric test. If I use this sentence, rate the statistical level, highly satisfied, dissatisfied, then this automatically becomes ordinal data. It won't stay in scale for long. Likert scale has its own property that you should check your attributes with some constructs, some more variables with one factor. I hope this is clear. So I'm not wasting more of the time. Yeah. So now you can do inferential analysis, that is parametric testing or hypothesis testing, if you have this kind of scale with you or this kind of questions with you. So in your question, you should know which question should go for nominal, which question should go for ordinal, which for interval, and which for the ratio data. So your first assumption is clear. First assumption that parametric test should have parametric data. Now let us go to the next one. Ma'am, we have time till 11:30.
Yes, ma'am.
Okay. The next assumption of the parametric test that you can use is the normality of data. Now, there is a lot of confusion regarding normality and stress. It's very, very, very simple. Nothing great about it. In mean, you have to take care of two things. See, I'll tell you something. In mean, if you know this basic fundamental of mean, I think there should not be a problem. See, in mean, the data that is collected, and so you do summation and then you divide it by the total number, right? This is how you derive at the mean. The mean score that you get is one thing. Second is difference. I am a non-statistical student, so I will use the language the way I understand statistics. Difference between each value from mean. You understand? You all understand this? Those who understand statistics, I am sharing this with the people like me who don't understand statistics so easily. So I have my own way of understanding stuff. So I'm explaining to only those participants who get a little confused. If you have this conceptual clarity, I think any test is easy for you to apply. That under mean, you have mean score. So you have all the data, you did the totaling or summation and you divide it with the number of unit and you get a mean score. So value which describes the entire data. Okay, done. Now, again, there is something called as standard deviation. That if my mean is equidistant or have some similar distance from each value. They are just different from 4 to 5 units, say for example out of 10. But if your data has something which is a huge distance, your mean score says 70 and the student has scored 25, the difference between the value is so huge. How can you represent that unit in your data then? Then that data is not homogeneous data. That's how we predict the homogeneity. See, normality refers to a specific statistical distribution called a normal distribution, or sometimes a Gaussian distribution or bell-shaped curve. The normal distribution is a symmetrical continuous distribution defined by the mean and standard deviation of the data. It should look like this. So what if the data is concentrating just to this, everybody saying just same thing? What will happen? Exactly, every participant, I asked them that how did you find this workshop? Highly satisfied, dissatisfied to 1. Everybody said 5. Do you think we can rely on such kind of data? Another question, what if the 100 students, of which 20 said not satisfied, 25 said satisfied, and then when you plot the data, you saw that there is no bell shape coming up. Side of effect ho gaya, side off ho jata hai samne, then there is no effect. You will not find any relationship of the workshop and the satisfaction level of the participants. But there has to be some homogeneity of the data, normality. The data should be normally distributed, means you don't have extreme values. Your data are concentrating towards mean. The standard deviation is less. More the standard deviation, the bell will come down. How to check the normality of data? So there are different ways of checking the normality of data. One is graphical way and the other is statistical way. In graphical way, there is a histogram. The one which I missed is scatter diagram. Scatter diagram also tells you box plot, PP plot, QQ plot. This all will tell you the when you plot your responses. Graphically, you can tell whether your data is normal or not. If your data are not normal, you cannot use mean. Hence, you cannot use parametric test. I hope you got the idea. If you remember, we plotted those marks of students, of 10 students. If somebody have got 35 and remaining never, all other have got around 70, 65, which shows that the teaching methodology used for the students is good enough. But there is one student who's got 35, the entire mean will be disturbed and the responses will not, the way when we plot it will not give you a good bell-shaped data. So there are values that they are creating a noise and not making the data normal data to go ahead with the parametric test. Correct? Under statistical way, there are Shapiro-Wilks test, Colombo-Simronov test. Then there is some also known as some Anderson-Darling test, which I have not mentioned here. Even that test is there. And there is a significant value and you can check whether data is normal or not. Some of the example of graphical presentation, if your data is something like this, it means your data is not normal. See in QQ in the normal plot, it is rotating. That line is the average and others are the variances or the units, and check the variances between the data. Even box plot will tell you whether your data is normal or not. So this was the second condition of normality. A Levin test will check the homogeneity in the data. They will not check the normality. Levin test is used to check the homoscedasticity in your data, whether there is some homoscedasticity in your data or not. Now, what is this? The assumption of the homoscedasticity means same variance in central and linear regression model. Describes a situation in which error term, that is noise of the random disturbance in the relationship between independent variables and dependent, is the same across all the values of independent variables. Now, maybe you get confused. Exactly what are you trying to say? We are checking that how far is each unit, how much the variations are there in your data, in short. If more of the variation, then I don't think you can go ahead with the parametric test, because again, it will disturb the mean. There is somebody who's raising hand. Shri Lakshmi, can you ask her to raise the question in the chat box? I can ask her or unmute, whatever you all feel.
Right now, you would like to take that question, ma'am?
I don't mind. What something emergency must have come up, maybe. Just raised her hand. Or else what you can do is, dear, you can post your question in the chat box. I'll answer it. So homogeneity of the data tells us about the how homogeneous are the data. See, always remember the basic fundamental of the research. Two things. It should not be completely heterogeneous. मानो 10 लोगों का डेटा दिया 10 आंसर आया कुछ भी कॉमन नहीं है what research and मान लो all are giving the same answer exactly same what research is always for the pattern something is moving something is variating but in a pattern so the heterogeneity if it is present in your data that the variances are huge between the independent and dependent variable then there is a problem with your data. Like for an example, I think I have taken one example here. Some example that if you want to study the family income and spending on luxury items, just keep these two things, two variables. We collected a data for family income and spending on luxury items. It was but obvious that when the family income was very less, the spending on the luxury items was less. True, good enough. But we also got an idea that when maybe those families whose income were very high did not spend on the luxury items. So independent and dependent variables have a different kind of variances. They did not follow the same path. Hence, we say it is not good enough for us to compare the means of such unhomogeneous or heterogeneous data. Then we cannot use mean here and hence we cannot use parametric test. I think now the concept of homogeneity is clear. How it is different from normality. Under homogeneity, we check the variances in both the variables that we are checking. With the family income increasing, definitely with a higher income you spend, with a lower income. But in the higher income, possibly, there is a mindset or an attitude of the people, no, we don't spend luxury items. We save, we do further investment. But the person who do not have any income will not have a luxury item. हाँ वो चोरी करके लेकर आता है तो बात अलग है, लोन पे लेता है तो अलग है. But then economically rational human being will not buy the car. Now next is okay, test for this is 11 test. Brown test भी यूज होता है, 11 test होता है. ANOVA भी बताता है कि whether those the data independent and dependent variable have homogeneity in the data or not. Linearity of data, the data should be linear. Now what is this linear? Again, to give you a simple example, with the increasing age your IQ should increase. 1 साल के बच्चे का IQ, 2 साल के बच्चे का IQ, 3 साल के 4, 5 years. What will happen after 15 years, 20, 25 years? Again your IQ will go up? No. At certain point of time, conceptually, the IQ will not go up with the increasing age. You getting my point? Even the height, certain age, yes, the height and age will have certain relationship, but after that it is not linear. It will stop somewhere. Learning curve. You learn something new with the time decreases and your adaptability increases, but after some time it will come down. So the regression for such kind of situation, we have a different test, non-parametric. And then independence of data. Data should be cross-sectional data and not the longitudinal data, which means the data that I have collected should not have a relation with other data. Example, the best way to remember this is in the experimental method. Say for example, I collected the data from you all once. So what the data that I have, 100 data are from the respondent once and I draw the conclusion. But what I did is I collected the data from 25 respondents today. Again, tomorrow, same 25 I am collecting. Again, on the third day, I am collecting data from the again same 25. What am I doing? Those answers will be related. I am collecting the data from the same group again and again. These are the longitudinal data for which they have a different test. You cannot use parametric test here. And these are kind of tests are mostly used when you do experimental study. So your data should be cross-sectional. You have collected the data once from all the respondents. So these 5 assumptions are very important to check when you use parametric tests. I hope you remember these 5 assumptions. Can you quickly write down in the chat box which are the 5? Five assumptions that you should remember. That these are the 5 assumptions that I should be having when you use parametric test. Okay. I just repeat: 1, measurement scale, homogeneity, normality, linearity, and independence of the data. 5 assumptions. I hope this, whenever you are now going, you are ready for the data, you will check. Now the question arises. Some may be thinking, ma'am, a question hai, what if my data are not normal? I cannot use parametric test. See, measurement scale is in your hand, that you are framing a questionnaire and you are asking in such a way that you get a data in scale form. But what if the data that you are receiving are not normal? There are more of outliers. There is a concept of outliers. In my examples of the marks that students have received, 60, 65, 70, 72, but there was one student who got 35, or some student has got 25. They are outliers for me. They will not give me a true result. So what can be done? So there are a method of transformation, deduction and transformation. But then, that requires a lot of, that is known as cleaning of data. But I think I can ignore that part as of now, because it again requires a lot of statistical knowledge. But I will help you with this, that yes, if your data is not normal, you can make it normal with some statistics which is available with us. One way of doing that is, when you collect data, like nowadays we do it online. During offline, how they used to avoid the problem of normality was, when the physical forms were collected, they just used to browse once. And when they said there are extreme people, that people have not marked up appropriate answers, you felt that if ऐसे देखकर tick करके दे दिया है, it means this is going to disturb my data normality. You can remove that question. They used to do it that way, right? Another way, in the online, when you collect, you can just browse those values. If you saw that out of 100, people are answering between 5 and 4, 5, 4, but there is one respondent answering 1, and all the response is 1. Some gadbad is there. Correct? So that way you can do it. So parametric test में कितने test होते हैं? Okay, one more thing. What we check in parametric test? See, there are 3 things you remember that you check. That comes to my mind is, 1, you compare the mean. I want to compare the satisfaction level of the male participants and female participants. I want to know the satisfaction level of the participants for this workshop and their perception before they started this workshop. 2 means I want to compare. Then I want to know the correlation, cause and effect relationship, regression. And I want to predict if X changes. There is a correlation says that yes, X and Y has a relationship. X will influence Y. Regression will tell how much. So if X is moved to 1 unit, how much Y will change? All this works on mean, and all these kind of things we check in the parametric test. So one is sample T test, which compares the mean. When you compare the pair test, there is some pairing of male-female satisfaction level, then they are doing some pairing. Then there is something known as differences that you are studying between the 2 variables. It is more on the category basis. Then you use ANOVA. On the non-parametric test, again you use the same thing. But Mann-Whitney, Wilcoxon, what they do is they work on median. So median nikal ke, mean nikal ke wo test run karte hain. They also give the result, but the results are not so good, that I already explained you. How to choose an appropriate test. So there are some checklists that you can remember. Check the nature of variables. पहले तो देखो तुम्हारे पास कितने वेरिएबल है, कॉन्सेप्ट कैसे बैठता है, IDV, DV, mediating, moderating. Which kind of data is this? You have asked them yes, no. You have asked them scale. You have asked them reflective scale. Then it is metric or non-metric put into a category. If it is a single sentence and scale, interval is used, but it is not the scale data. It will not come under metric. Do you like research subject? Highly, matlab most like to least liked. So, ma'am, this is scale. No. I asked you, do you like to collect data? Are you interested in finding new facts? Do you like to do a review of literature? So 4 or 5 things will describe one factor. Then that becomes reflective. There you will get an appropriate answer. Number of categories in the case of non-metric data. If the data is non-metric, one of your variable is non-metric, and that non-metric ki categories kitni hai? 2, 3, 4, 5. If it is less than 2, which kind of test I can use? If it is more than 2, which kind of test I can use? So then you have to remember variables, number of variables. If you have 2 independent variable and 1 dependent variable, or you have 1 independent variable but 2 dependent variable, something like that. Multivariate analysis and metric, non-metric, and categories. Now see, you will have the answers ready for you. If you have 1 variable, univariate study. I want to study the marks of the students in the class. I want to study the how many of them are using mobile wallet nowadays. Mobile wallet is 1 variable. How many are using it just becomes an category. So it is an non-metric data, count percentage. Frequency of using, it is a metric data, mean 1 sample test. You have no other variable to compare with. You can draw mean, that's it. If your dependent variable, DV is dependent variable is 1, independent variable is 1. But under that, if the data is metric, if you are using scale or ratio data, you will use sample regression and hypothesis testing of t-test, f-test, one-way ANOVA. Now, what is this t-test, f-test, and test, z-test? I will cover it in the last slide. If the one of your dependent variable is binary, is non-metric, and your independent variable is metric, you use binary regression. ये permutation combination से आपको आंसर मिल जाएगा exactly कौन सी टेस्ट यूज करनी है. T-test, when you have only 2 categories, the answers were in 2 categories. But if the answers were in more than 2 categories, male, female, and others, F-test. Again, this dependent value is 1, metric, non-metric, check. And when then IDV is more than 1, if it is 2 independent sample t-tests, all are metric, multiple regression, all are non-metric, and way ANOVA, 2-way ANOVA. So this is how you identify which test you should be using. If you have these circumstances, how many independent variable, which kind of variable, whether the variable that I am studying were collected in the form of metric data or non-metric data. And hence, when the questionnaire contains more of questions like yes and no and non-metric, a very poor form of tests are conducted, which works only on median, and the results are not so appropriate. Okay, I think I didn't include the slide for t-test, f-test, and z-test. If the sample size is less than 30, you use t-test to compare any mean. If the sample size is more than 30, use z-test. Those tests automatically become z-test. But when do you use f-test? F-test का भी option आता है जब तुम data analysis करते हो. When the response categories, the question categories has more than 2 categories, then you go for F-test. So this is how you study your hypothesis testing. There are a number of questions that must be coming in your mind, because what I have attempted to do is I'm sharing this information with the commerce economic background students or the participants, and not pure statistics. So I've refrained myself using more of statistics here. So I guess, yeah. So these are the a group of family. When you have one sample, you have two samples. What can be done? What is this one sample, two sample? If you are studying a behavior of working woman and non-working woman, two samples. People staying in urban area and rural area, two samples, that way. So now let's attend questions here. Ma'am, I have doubt with regards to t-test and exact. It is that the test is used, the sample is less than. Yes, that's what I said. Is generally CT tests are applied testing. Is there any like, no, see what happens when you apply test, we look at the t value, but they are known as Z test statistically. Descriptive analysis and inferential analysis. See, when you collect the data and you prepare a tabular form, how many were male, female, and from which region they are, you are just explaining it and putting a data in a tabular format. You are describing the data. Descriptive analysis. You are not making any analysis out of it. But when you are drawing some hypothetical situation, whether there is some relationship or there is an impact or there is a differences, then you can say it is an inferential analysis. Okay, one more thing. A small suggestion. In your research title, avoid using word impact if you are not doing experimental study. See, I'll give you an example. I asked you a question here in your, just a second, huh? तुम्हारा ये वर्कशॉप की एनालिसिस करते हैं हम सेटिस्फैक्शन लेवल. So then I say that okay, so we assume that through this RM workshops, the knowledge of the participants for the RM increases, it enhances. So can I say that there is an impact of RM workshop on participants' knowledge? Now, why do I say that? I feel, this is my understanding, why should not I use impact? See, how will I study? There are 2-3 ways of doing this. One is, I will ask a survey from you all, saying that you please give your feedback regarding the, did it help you to gain more knowledge? Correct? So conceptually, तो ऐसा हम लिख ही नहीं सकते that there is no influence of the participants' knowledge. We will say satisfaction level of the participants. In this case, you can do inferential analysis. You can do questionnaire-based testing. But what if you want to know the impact? Impact can be studied only in 2 ways. One is test retest. I will first take a test before the workshop starts, put a 10 question across you all, you will answer, and I have some performance with me. After the workshop is conducted, I will again check the response, the results, and check if there was a substantial difference in the results. Initially, people got 50%, now they got 75, 70, 80%, which means, yes, workshop was impactful or had a great impact on the participants' knowledge. Correct. Another way can be, if I have 100 researchers with me, of which I will allow only 50 participants with me, I will give them one concept. I will explain these concepts. I will conduct test of 100, 50 constant group who have not attended my workshop, 50 who have attended my workshop. And then I will collect the data and I will compare. I will pair them and I'll compare the results. That will give me an impact of the of something on something. That is an actual experimental study. But once you say, it is very difficult. If you are not able to do experimental study, avoid using word impact. You say influence or there is some relationship. What? Any other questions that you all have? I think I wind up a little early today. I didn't cover few more things. The data is not normally distributed, we assume it is normally distributed and we go for a parametric test. According to central limit theorem, though the data is not normally distributed, how can you, if the, see what happens when the data is not normal, it means it has extreme values, it has outliers, they're not normally distributed. And if it is not normally distributed, definitely it will affect the mean. And once mean is affected, then you cannot use parametric test. Then you have to obviously use median, because median क्या करेगा, extreme values को ignore करके result देगा. So all the best to all the researchers there. I hope I have tried my best to justify the topic. In these 2 days, you must have learned what is hypothesis, how should you derive hypothesis from your variables, and from variables, from where you get your variables, it is from review of literature. So now just understand the relationship between a kind of ROL you do and your test results. If your ROL is good, your variables are nice, you prepare a proper systematic hypothesis, accordingly you choose a proper measurement of scale. मतलब questionnaire बराबर बनाया, उसमें responses वैसे collect किए, then you can go for a nice test and then your results are good and then your paper will be accepted in the good journal. That's how the whole logic is.
Participants, if there are any more questions, you can put it in the chat box. Otherwise, we can wind up with this session. Ma'am, I don't think there are any more questions. So shall we wind up?
Kyati ma'am, you did a wonderful job. You did a wonderful job. You had your own apprehension about it, but you were wrong actually. You can really do wonders. Yes. Very nice. I think Sri Lakshmi, you can go ahead. We are actually on time. Very nice.
Yes. So I would like to take this opportunity to propose a formal vote of thanks. I would like to thank the resource person for this session, Dr. Kyati Vora, for conducting such an engaging session. Ma'am, with the simple examples, pictorial representations, exercises to test our level of understanding, and minute details of varied concepts, it has definitely boosted our confidence of many of us in contributing to our and continuing our research work. So thank you so much for this wonderful session. I'm also grateful to the management and principal for promoting and being supportive of such research-based workshops. I express my gratitude for the conduction of such workshops by our IQAC coordinator and vice principal, Dr. Riji Santosh, wherein we get to learn from the best and never settle for the less. And I'm grateful to our vice principal, Professor Sandesha Shetty, and also the organizing team for their constant support. I would also like to thank our technical team for their technical assistance throughout the session. A big thank you to my colleagues for attending the session and being such a support. And at last, but not at all the least, a special thanks to all the attendees for your active participation and cooperation. Without you, it wouldn't have been possible to conduct such a engaging and enlightening session. So thank you to all. Our second session will begin at 11:45. So you may stay in the meeting or kindly join on time. So thank you so much.
Take care. Bye.
Thank you, ma'am.
Thank you, Kathy ma'am. She left.
Yes, ma'am, Sheila.